Naturally, as an ethical hacker, you're going to try to do some web app pen testing. You might not do it in great detail. You might use automated tools. That's okay. So let's just put it all together. You have a bunch of web app hacking tools that will help you. From the Burp Suite to Teleport Pro, HTT Track, Metasploit is a great one. Web Scarab, Cookie Digger, Instance Source, W3AF. Look at all these. Curl, Black Widow. Curl is actually a Linux command where you can just get HTTP content directly. So lots of tools. This doesn't even begin to cover how many tools there are. When you do web app pen testing, try to identify and analyze and report on vulnerabilities in a web app. Use automated tools to help you. Make sure that whatever automated tool you have can actually validate, not just do a vulnerability scan, but can actually prove, like by stealing something. The validators like Metasploit will do that. You perform this by conducting a series of methodical and repeatable tests. And you, of course, identify ports, you verify vulnerabilities, you remediate the vulnerabilities. This is the purpose of the pen testing. You could gather information, analyze robots.txt, which basically says, please don't scan me, Google. You could do search engine reconnaissance. You could identify app entry points and web apps, analyze input and output coming from the option head requests, analyze error codes, test for recognizable file extensions and directories and types. Like I said, there are plenty of tools that'll do this for you. Examine available page sources and fingerprint the TCP and ICMP and other services. You could do testing of SSL and TLS, like can we strip the SSL? You could execute infrastructure configuration management testing. See how the thing handles file extensions. Verify the existence of maybe some old backup files or old files or unreferenced files that shouldn't be there. Test for HTTP methods. Execute testing infrastructure app admin interfaces. See if we can get in as admin and do stuff we're not supposed to. Test for vulnerabilities in authentication, like remembering password or password reset. Test for browser cache and logout management. Test for CAPTCHAs. Test multiple factor authentication. Look for race conditions. Now, I think I've mentioned it before. A race condition is basically a time of check, time of use test. I have been authorized to do something as an application, but it takes me a moment before I actually do it. There's that little period of time where someone can race in there and sneak in their own malicious code. Test for session management and how that's structured, for cookie attributes and session fixation, and exposed session variables and cross-site request forgeries. Make sure that, see if you can test for path traversal. Like directory traversal, or HTTP request tampering, or cookie parameter tampering, or privilege escalation. Test for reflected cross-site scripting and stored cross-site scripting and DOM-based cross-site scripting, all those ones we talked about before, or cross-site flashing, or SQL or LDAP or ORM or XML, all these injection mechanisms. See if your testing tool can do any of these injection types. Test for SSI injection, server-side include. Test for XPath injection, IMAP or SMTP email injection, or code. Make sure that the code is actually tested. Try to execute operating system commands, buffer overflows, any other type of vulnerabilities, HTTP splitting. Do denial of service. Test for SQL wildcards and locked customer accounts and buffer overflows and user-specific object allocations. Get some good comprehensive web app testing tools, and they'll do all of this for you. Test for user input as a loop counter. In other words, could we just have a loop that counts up? Might be part of denial of service. See if we can write to disk and fill up their disk. Test for appropriate resource release. In other words, when we're done, is the RAM, the memory, released back to the operating system? See if too much data is stored in a session. Collect information on the web services, test WSDL, check XML at both the structural level and the content level, test REST and HTTP GET parameters, test SOAP attachments, and see if you can do any replay testing. Test for some of the programming languages. Test them. Ajax, JavaScript, HTML. Use a proxy to observe the traffic. If you don't know how to do this, get a web app developer to help you do this. There are whole testing frameworks that you can use. Kali Linux has all sorts of web app stuff. Metasploit has all sorts of web app stuff, and Metasploit is actually installed by default in Kali Linux. You want a whole framework for doing just cross-site scripting? Use Beef. Or even PowerSploit, which is a bunch of malicious PowerShell commands created by third parties, not Microsoft. So you would use PowerSploit against IIS, Microsoft Web Servers. Okay, let's review what we know. Organizations have been heavily relying on web apps and Web 2.0, which is all about collaboration and user interactivity. All those apps and services are being increasingly targeted by attackers. There are so many vulnerabilities, injection flaws, SQL injection, cross-site scripting. We can exploit input validation flaws to execute remote app attacks or web app attacks. The majority of flaws are because of misconfiguration or bad coding. Examples of countermeasures, we saw lists and lists of them. Secure app development is your number one thing. Use a web application firewall, a WAF firewall, and input validation. And with that, let's get on to our lab, hacking web apps.